Bingo.
Okay, we're in section 4-5 in theorem 1. Well, that was just so professional. Why is this marking so professionally? Theorem 1. Okay, if first of all we have to discuss what the unit step function is. So u of t minus a. So let's say I got u of t minus 1. What is that? Well, that's something that is 0 until I get to 0, and then goes up to 1 because it's a unit step function, and then at 1 it goes back down to 1 and stays at 1 forever. So if I have a u of t minus a, then that's a function that's going to be at 0 until I get to 0, then it goes up to 1 because it's a unit step function. It goes out to a, wherever a is, and then at a it drops down to 0 and stays at 0. So that's what a unit step function is. So for whatever reason, and I can't think of any good reason to do this except being in section 4-5, if I want the unit step function, the Laplace transform of the unit step function going out to a times f of t minus a, and I think that's the problem. The problem that this thing is in touch, and that's probably the issue. All right, now we're better. T minus a, then I end up being e to the minus as f of s. And if I go the other way, if I want the Laplace transform of inverse Laplace transform e to the minus as, f of s, then that becomes the unit step function f of t minus a. That still isn't doing all that wonderfully, is it? Am I going too fast? Is that the problem, do you think? Am I talking too fast? All right, is there any other theorem in the whole chapter? Yes, theorem 2. With a little bit of luck, we won't need theorem 2. Oh, look at that on page 311. Isn't that cool? There's the hyperbolic tangent sitting there. Just what we need, hyperbolic tangents. Okay, so that's the what?
What are those little C's after the brackets?
Who?
Go back to that page real quick. What are those little like C's after the
Right here?
bracket?
Those things? Those are brackets.
Oh. C after the bracket, like there you go, right?
You mean this U?
Oh.
Is it? You mean the U?
Yeah, and then what's in that?
T minus a.
That's
F of t minus a. Okay, so you want some practical thingy. Okay, so let's say I got a sine function. So there's my sine function, f of t, right? And I've got some electronic circuit. So I got a resistor, and I got a capacitor, and I got an inductor, right? And I'm going to send into this thing a signal. And the signal is going to look like that. So this is the unit step function, t minus a times f of t minus a. And so I'm going to just take, not the whole thing, I'm just going to go and take a little part of it and send it into there to energize it. So that's what I'm doing. I'm sending some small portion of a signal into a circuit to see what happens, see what the response is. I've got a spring, and I've got a 10 kilogram thing here, and I'm gonna push down on that for a half second to energize it, to get it moving up and down to see what it's doing. So I'm using the unit step function to say that force I'm putting on it is only going to be there for a short period of time. Okay, does that make any more sense? No, okay, that's fine. We're going to try problem number 2, and I emphasize try. Let's see, f of s is equal to e to the minus s minus e to the minus 3s divided by s squared. It's going to be a long day if I can't even write the problem. All right, so that's what we have, and what we want to do is, find the inverse Laplace transform. And then sketch the graph. Well, we're not going to sketch any graph. Well, maybe we'll sketch the graph. We'll think about it. It's not too much of a pain in the ass. All right, so that's that guy. And the only thing we have going for us is theorem number 1. Okay, so go back to theorem number 1. Okay, so the inverse Laplace transform of e to the minus s, e to the minus s, 1 over s squared minus e to the minus 3s, 1 over s squared. Okay, so I've rewritten the problem using my glorious 9th grade algebra skills. I'll now apply the theorem to the problem, and it says that this is going to be the unit step function of t minus 1, because there's a 1 sitting there in front of that s, minus 1 times the function. Okay, now the Laplace transform, the inverse Laplace transform of 1 over s squared is t, right? Yes, it is. So it'd be t minus 1 and then minus unit step function t minus 3 t minus 3. Okay, so I've written the inverse Laplace transform just like I wanted to. Now I'm going to graph the function. Okay, so the function of t minus 1 means that when I am at 1, I'm crossing 0. So it's a function that looks like this. Okay, that's 1, this is 1. If I look at t minus 3, okay, t minus 3, so this is 3, and I'm going to look like that. So this is t minus 3. And now, the unit step function, t minus 1, goes positive, is negative until I get to 1, goes to 1, and then comes back down. Of t minus 3, did I run out of colors yet? Is going to be negative, is going to be 0 until I get there, and then it's going to come out to 3 and then go down. Okay, so that's what I've got. Is that perfectly clear yet? This is why we don't do graphing. So I'm going to have this guy, t minus 1, and 0 is going to be less than or equal to t is going to be less than or equal to 1. And then I'm going to subtract from that t minus 3, for 0 is less than or equal to t is less than or equal to 3. So what does that look like as a graph? So I've got, there's my graph. So the first guy is going to look like, I'm going to come that way, I'm going to come here, I'm going to go to there. So the first guy is that. The other guy I come down here to minus 3, and I'm going to come up like that to there. The purple guy is subtracted, so it's got to go up on top. Okay, final answer for my graph. Say the guy on top is doing this, but I'm subtracting something that's doing that. Okay, so it's going to be at 2 until I get out to 1, and then it's going to come down like that until I get out to 3. Okay, so now I've found the Laplace transform, and I have graphed the function, even though I really didn't want to. All right. What?
That's not what the back of the book has.
Well, I don't care what the back of the book says. I really don't care. Which one? Is that not what the Laplace transform is, or that's not what the graph is? Well, I don't care then. All right, as I was saying, we're not graphing. So where's my eraser? There we go. We're not graphing. This is not a graphing class. Forget that. Okay, so there's my Laplace transform. It is correct. And you guys are supposed to do odd, odd. So I did 2. I can skip 4. I'm going to 6.
How did you get? Go back.
Number 6. Are you interrupting the progression of the class? What I get? Yeah, never. Okay. What?
U equals U. How did you get all of that?
Where?
Equals U. And then,
You mean this line?
Yeah.
I'm on page 305 looking at the theorem, and it's telling me what to write. So I'm on 305, and I'm looking at line 3b, and I'm writing exactly what 3b tells me to.
3B.
Yeah, line 3b in the theorem. Theorem 1, there's a 3a line, there's a 3b line in parentheses.
Oh, because you wrote it down first. Okay.
Right.
Gotcha.
Okay. So I wasn't pulling it out my rear end or anything like that. Not that I particularly like these problems. This is a section of the book that I enjoy skipping over as much as possible. Okay, so now we're going to look at f of s.
F of t minus a in that 3D formula.
What are you talking about?
Oh,
That's exactly what I did.
where's the F?
Because 1 over s, the inverse Laplace transform, 1 over s squared is t.
Mm-hmm.
So that's the t, and there's the minus a. A is 3.
Oh, where's the, it goes U, and then where's the F in front of
There's
the
the u right there.
Where's the F?
Where s? What
F.
s? There it is right there. That's f right there. T minus 3 is f.
All right, now I'm lost.
All right, we'll try this a different way. 1 over s squared. What is the inverse Laplace transform of 1 over s squared?
T.
1 over t. Right. So the inverse Laplace transform of f of s is we're going to have f of t minus a is what the theorem says, right? And this isn't 1 over t, this is t. So this is f of whatever, f of t minus a is t minus a. So we'll try this again one more time in a different color. F of x is equal to x. What is f of x minus 4? X minus 4. Is it not? 3 people are shaking their head except the one asking the question. Okay, I'm going to do it again. Y of x is x squared plus 3x plus 4. All right, that's what y of x is. I want y of x minus a. What is that?
Oh,
X
okay.
minus a squared plus 3, x minus a plus 4, right?
Yep.
Okay, so if 1 over s squared is capital F of x, then f of t is going to be t, and f of t minus a is going to be t minus a. Yes. It is that simple. Yes. Yes, that simple. It better be that simple, otherwise I couldn't do it. All right. I'm going to try this again. F of s e to the minus s over s squared plus pi squared. Okay. So that's what I have. I have e of minus s times s over s squared plus pi squared is my f of s. Okay, now I want the inverse Laplace transform of that stuff. Okay, so I'm going to have, I'm not going to write down f of t here because that would just be confusing. So I'm going to have, I'm looking at my theorem again, I'm going to have the unit step function t minus 1 and s over s squared plus pi squared is the cosine function. I'm pretty sure, I'm looking, and yes it is, it's cosine pi t from number 10 off my Laplace transform table. So it's going to be cosine of pi minus 1 and now I'm done, except for doing the graph, which I'm not going to do. All right. Again, that was doing number 10. Number 10, oh, look at that. Okay, so I've got f of s is 2s e to the minus pi s minus e to the minus 2 pi s divided by s squared plus 4. Okay, I'm going to rewrite that. Where should I put the 2? All right, I'll go e to the minus pi s 2s over s squared plus 4 minus e to the minus 2 pi s 2s over s squared plus 4. Okay, so I'm going to, using my theorem, I'm going to take the inverse Laplace transform. I'm going to have unit function t minus pi times the 2, the sine, who wrote the sine there? Cosine 2t minus pi, has to go like that, minus unit step function t minus 2 pi 2 cosine 2 t minus pi in parentheses, in another parentheses. Okay, good enough? Okay, so that's 10. We're skipping 12. I'm going to 14.
Oh, very good. Yeah, it's pretty funny.
14. I got f of t is equal to cosine pi t, cosine pi t, and this is true between 0 and 2. Between 0 and 2. And it's 0, f of t is going to be 0 for t greater than 2. All right, so I got that. So I'm going to rewrite that as unit step function t minus 2 cosine pi t. Okay, so I'm going to change that to read that. And then I'm going to look at my theorem, and I'm going to say, how come I don't have I don't have what I want? Why is it that I have something different than that? Reverse Laplace transform. Okay, that's fine. Unit step function. Cosine 2t greater than 2t, f of t greater than 2t. So that's going to be okay, I'm looking on page 307, and I say, if I have cosine 2t between 0 and 2 pi, and I have 0 between greater than 2 pi, then that's going to end up being, f of t is going to be 1 minus the unit step function of the cosine 2t, which is going to equal that other thing. So I'm going to get rid of this for a moment. And I'll thank you very much for the biggest eraser I can possibly have. So I'm going to change this to f of t is equal to 1 minus the unit step function t minus 2 times the cosine of pi t. And I'm going to say, well, that is equal to the cosine of pi t, cosine of pi t minus the unit step function of t minus 2 times the cosine of pi times t minus 2. Okay. So I'm sure everybody believes that garbage. And now if I take, that's my f of t, and now I'm going to take the Laplace transform of that, and I'm going to get f of s is equal to s over s squared plus pi squared minus e to the minus 2s e to the minus 2s e to the minus 2s s over s squared plus pi s. Anybody look in the back of the book and tell me it's right, or don't bother? It's perfect. All right, so that was 14, 16, doing 18 next. I'm going to do 18 next. All right, I'm going to do 18 next. 18. Okay, so f of t cosine 1/2 pi t between 3 and 5, and f of t is equal to 0 everywhere else. Okay. Okay. All right. Yeah. Yeah. That's what I want. Clear as day. Okay, now, before we do this problem, we're going to go back to the top of 305 and tell you exactly how hosed I am. The unit step function, t minus a. This guy is equal to 0 for all t less than a, and 1 for all t greater than or equal to a. So I told you exactly the wrong thing, and that's why my graph didn't work out very well, because I obviously didn't graph it right. So if I knew what I was doing, I would have done that. Okay, so that, once we go back and we look at the unit step function, it starts at 0, it goes up to 1 and stays there forever. Goes up at a. 0 until I get to a, and then goes up forever. Okay, so now that we know that that's the case, at least we think we know that's the case, we're going to go back to 18, and we're going to look at this guy. And basically, we want a unit step function t minus 3, and then when we want to subtract the unit step function t minus 5. Okay, so if we go and at t minus 3 we go up, and then we subtract it minus 5, we have something that goes up at 3 and down at 5, and that's what this is. And then we want that unit step function times the cosine of 1/2 pi t. All right, so now I'm looking at the top of page 307. And I'm going to rewrite that as unit step function t minus 3 cosine 1/2 pi and we're going to go with pi 1/2 pi t minus 3 minus unit step function t minus 5 cosine 1/2 pi t minus 5. All right, now that I've done that, I'm going to take the inverse Laplace transform of the whole thing. I think that's what I'm doing, right? No, I'm not. I'm taking the Laplace transform of the whole thing because I want the Laplace transform. I'm going to take the Laplace transform of the whole thing. And I'm looking at the theorem on page 305, and I'm saying that that's going to be e to the minus 3s. E to the minus 3s. What am I going to do with that?
And the parentheses with the law of the Laplace transform around it. Like the second two terms, is that ut minus 1?
Okay, that's a cosine guy. So I think it's going to be s divided by s squared plus pi squared over 4 minus e to the minus 5s s over s squared plus pi squared over 4. All right, I think I'll stick with that. Let's move on to 32. I don't want to do 32. 32, 34. We'll move on to 36. That looks like more fun. 36. For in problems 36 to 40, the values of the elements of the RLC circuit is given. Solve the initial value function. Okay, so that's what we're going to do. All right, so we're going to do 30. After we get done with 36, we're going to go to the next section. I just feel it in my bones. Number 36. All right. L is 0. So 100 I plus 1 over 10 to the minus 3 integral zero to t I of tau d tau is equal to 100. Okay, well, I'm thinking that we're not going to do that. We're just going to go on to section 4.6. All right, section. What do you mean, what on? How do I know? I have no clue.
So does that mean we don't have to worry about 4 or 5?
Yes, I wouldn't worry about, well, I'd worry about 4 or 5, the beginning problems, but not 4 or 5, the ending problems.
The beginning problems?
Yeah. So 4 or 5, 1 through 10, for example.
Okay.
Yeah.
And the rest I can...
But I wouldn't worry about, I wouldn't worry about any of them. Okay. So now we're
asking why 18 doesn't have a back of the book.
yeah.
Okay.
Forget about 18. I was lucky last week. I got 10 in a row right. What more do you want?
Yeah. Halfway through, you're going to keep going.
See, the issue is that we don't really want to be done with section 4.6 because they'll have to take the chapter 4 test on Thursday.
Well, then explain 18. Why doesn't match up in that case?
I have no idea.
From 6 until the end of the semester.
All right. So you want me to Okay, so I'm going back to number 18. All right, so there we are. Number 18, not a problem. There it is. So we come here, we go there, and we, that's not cheating.
That's cheating. We don't get it.
That's not cheating.
To find an answer. In
Open.
that case, I can use Maple.
You know, I'm not, there's nothing cheating going on here.
Maple, that won't help you.
What is that one I gave it for?
The same answer we put in.
The what?
The same answer we put in.
No, it gave us some weird answer that I've never even heard of. What was it?
Probably like a double integral or something.
No, I've seen those. I don't know. It was like a name. I think. It was weird.
What are we in, chapter 4? All right, so this is section 4, 5, number 18. All right, section 4, 5. Number 18. All right, and we'll do a okay, and it's the intent, it's a thought of the class that my 18 is not algebraically correct is the same as the answer in the book. That's the thought that the class has. Let's see if there's any truth to that at all. All right, so I got 2 pi. Where's my 2 pi? Okay, there's my e to the minus 3, and there's my e to the minus 5, and there's 4s squared, okay. All right. So there's that. Pi over 2. Why do I have a pi over 2 up there? Why would I have a pi over 2 up there? That doesn't make any sense. Why is this a sine guy? Why did they change it to sine? Wow. If I would have changed it to sine, I probably would have got the same thing. So, I have that, they have that. But they went from this to sine. Now, why in the world would they go from there to sine? Okay, 4, 5. There's the 4, 5 problems. 4, 5. So they didn't go to sine in 30 on the top of 307. They kept it in cosine. And why are they pi over 2? Well, there's a pi over 2. There's a pi. Okay, so I see a pi over 2. But what makes them think that cosine of pi t over 2 is the same as sine pi t pi over 2?
Okay. Okay, why is Maple not opening?
No, not as many below. So what we're going to do is we're going to go and go to the graphing tools. And we're going to put cosine of pi 3.1415 divided by 2 times t times x, and we're going to say y of x equals. Okay, and that's pi over 2t right there, that guy there. Okay, and we're going to put that in, and then we're going to add another one, y of x equals sine pi 3.1415 divided by 2 times t minus 3, x minus 3, parentheses, except, what's the problem? One too many sets of parentheses, that's the problem. Okay. Error. There are no suitable for cosine blah 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 blah. Thank you very much, Mabel. All right. So I think my view is the answer in the back of the book can't be right, because those things can't be what it says they are. They're saying that cosine pi t over 2 is the same as sine pi t minus 3, and the same as sine t over 2 pi over 2 t minus 5, and I don't see that. When I put a 0 in this guy, I get a 1. When I put a 0 in this guy, I don't get a 1. Do I get a 1? I do get a 1. Shit. When I put a 0 in that guy, do I get a 1? Darn, they are the same. Bummer. Those are the same.
Do you get mad when you're wrong on an answer?
Hmm?
Do you get mad when you're wrong on an
Never.
answer?
Never occurred to me at all to get upset about it.
If you put 0 in for cosine, you get
1.
0, right?
No, the cosine of 0 is 1.
Oh.
And the cosine of minus 3 halves pi is 1. And the cosine of, now is the cosine of minus 5 halves 5? 5 halves. 1, 2, 3, 4 is not 1. So yes, but there's a minus sign here. See that minus sign?
Yeah.
So it is correct. So I think that what they did is correct, but I have no idea how they did it.
Some trig identity.
Yeah, it's some trig identity that I don't know. That just happened to work, that I don't know. That's even worse. All right. So now we're looking at well, I don't know. 4, 6 looks like a giant pain in the rear end.
Yeah, that's better for all the things.
Alright, I think what we should do is cancel 4, 6,
And then come back with questions later.
and Thursday just do the chapter 4 test. I think that'd be the best thing. Because all we're doing is just going away from what the test is on, which is 4, 1, 2, 3, 4, and 5.
Or what if we are
1, 2, 3,
schedule?
1, 2, 3, 4. No, we're not ahead of schedule.
Are we behind?
Yeah, no, not really.
What if on Thursday we ask questions about
Chapter 4.
over all sections, and then we take it on Monday?
Tuesday?
Yeah, I'm sorry, Tuesday.
Okay, how about this? This would be better. Why don't we go over questions on sections 1, 2, 3, and 4, because section 5 isn't on the test,
Okay.
and section 6 isn't on the test. That way we won't waste time trying to solve problems that I have to pull out of my ass that I can't solve.
Okay, so we
Yeah.
can say 5
That works out.
Would you mind doing 4-3, number 33?
Like right now, immediately?
If you want to.
That'd probably be a worthwhile thing to do. Is it hard?
I can do
Oh, hell yeah.
4, 3, number 33.
43%.
How could this guy possibly be hard?
I don't know,
I got 20 million.
Okay, so I'm in 4, 3. I'm in 4, 3. I'm looking at 33. Okay, so I've got x to the 4th power plus x is equal to 0. Is that the problem? And x of 0 is equal to x prime 0 is equal to x double prime 0 is equal to 0, and the third prime guy is 1. Okay, so I got the problem written down. Now I got to square away some of my stupidity here. Okay, so I'm going to take the Laplace transform of the whole thing. Okay, I'm looking at my Laplace transform, and I see the first and the second derivative, right? But I don't see the fourth derivative thingy. So the fourth derivative is going to be in the same way. I'm going to get s to the 4th f of s minus s would be x of s minus s cubed x at 0 minus s squared x prime at 0 minus s x double prime at 0 minus x triple prime at 0 plus x of s is equal to 0. Okay, so that's the problem that I got. So I look at it again, and this is 0, that's 0, that's 0, and this guy
That's supposed to be up.
this guy is 1. So I'm going to have s to the 4th plus 1 x of s is equal to 1. So I'm going to have x of s is equal to 1 over s to the 4th plus 1. All right, now what was I supposed to do with the problem? Use Laplace transform to solve the initial value problem. Okay, so do I have an s to the 4th plus 1 guy here? And on my Laplace transform tables. And the answer is no, I don't have one in my Laplace transform table. So Where am I going to get an s to the fourth minus 1 guy from? Okay.
What is the,
Okay, s to the fourth plus 1. Alright. There's no partial fraction I can do.
this 4-3, you said 13? What? Yeah, it's even worse. No, I got that as my answer earlier. When I worked at 20, so.
Okay, I found it. S to the fourth plus 1. It's number 26 on page 296. Okay, so on page 296, problem number 26, wanted us to find the inverse Laplace transform of 1 over s to the fourth plus 4a to the fourth. And that's going to be 1 over 4a cubed times hyperbolic cosine at sine at minus hyperbolic sine at cosine at. Okay, so that's number 26, page 296. Okay, so I'm looking at the inverse Laplace transform of 1 over s to the fourth plus 1. Okay, so that's what I want. I find that a is equal to, so 4a to the fourth has to be 1. So a has to be 1 over the square root of 2. Does it not? So if a is 1 over the square root of 2, then the 1 over the square root of 2 raised to the fourth power would give me a 1 over 4. This would make this a 1. So this guy is going to be 1 over 4, 1 over the square root of 2 cubed times hyperbolic cosine 1 over the square root of 2t sine 1 over the square root of 2t minus hyperbolic sine 1 minus the square root of 2t cosine 1 over the square root of 2t. Now, I probably wouldn't leave it that way because my 9th grade algebra instructor would tell me that I would have to go and rationalize my denominators, right? So this is going to be 2 over the square root of 2, which would be the square root of 2 over 2, right? So that's the square root of 2 over 2. This is 2 over the square root of 2. So that'll be square root of 2 over 2. This is going to be the hyperbolic cosine of square root of 2 over 2t sine square root of 2 over 2t minus hyperbolic sine square root of 2 over 2t cosine square root of 2 over 2t. Now, how would you know to use a previous problem to solve that problem? Well, you probably wouldn't. Neither would I. I just got lucky. Is that what the back of the book says?
Yeah.
So I have a
With
question.
written the way I have it written?
Well, they put 1 over square root of 2.
Oh, those assholes.
They just left it in the
Right.
A format and then said A equals 1 over square root of 2.
Oh, okay. Well, that's even more of an asshole. Now, did I assign doing problem number 26 in that section? No.
Okay, so for
That's good.
the A equals 1 over square root of 2, is that
Yeah.
because when you plug it into the 4, when you plug that A into the 4 and it's to the 4th, it equals 1?
Yes, I have 1 over s squared plus
Yep.
1, so
So it
that
equals
4,
1.
yeah, so that 4a to the 4th has to be the 1.
Okay.
In order to make it a 1, a has to be 1 over the square root of 2. I think that's the first time I've done that problem. I know that's the first time I've done that problem.
Can you go all the way down to the final answer, please?
My final answers are the book's final answer.
This one.
Yeah.
Just, the old analysis.
That was particularly nasty, wasn't it? Yeah.
Okay.
Why don't we put it in Maple and see what Maple thinks the answer is? I mean, why have Maple, you know? You can't do that. So we're going to go with, we want y, we want x. Right, x with respect to t. And we want a 4th order derivative. And we want a 0 order guy. Okay. And we want those two guys added together equal 0. Thank you very much. It won't allow me to have a 4th derivative in my thingy. Why not? It says so right here, 4. What's wrong with that? Oh, I know what's wrong with that. I don't have an equal sign. Equals 0. That's what's wrong with it. All right, so we're going to add that. Boom. Okay, that's good. And then my conditions are going to be x at 0 is 1. No, x at 0 is 0, right? X at 0 is 0. X at 0 is 0, okay. X prime at 0 is 0. X prime at 0 is 0, add. Okay, and then we're going to have x double prime at 0 is 0, add. And then we're going to have x double prime, triple prime at 0 is 1, add. Now, why did those other guys complain? All right, solve. And we're going to use Laplace transforms. Okay, we're going to use Laplace transforms to do it. Look at that. Is that what we got? Yeah, I guess so. And notice it's written the way I wrote it, like my 9th grade algebra instructor told me to do. Now, but they put the minus guy first. I put the minus guy second because, why did I put the minus guy second? Because he's second here. All right. Hey, anything else, or should we go home?
Yeah, that's all.
Yeah.
One of my other questions over here is it for you.
All right, if you must. But to get the problems 23, 24, 25, 26, you basically have to do all of them because they build on top of each other to get to those things. And we didn't do those, so it probably wasn't fair to assign 33. No, that probably wasn't a fair thing to do. I should probably rethink the entire 4, 5, and 4, 6 set completely.
We just rethink the whole class.
Well, I'm not going to rethink the whole class. The whole class is perfect.
So if you can understand it, enough to rethink it all.
Well, the real issue is, do I bother to put this video on the web anywhere? That's the real issue.
No.